Hey math fans, in this video we're going over chapter 8 section 4, that's adding and subtracting rational expressions. Here we are going to be adding and subtracting fractions with x somewhere in the fraction on the denominator and possibly in the numerator as well. And all these examples will have unlike denominators, meaning the denominators are not the same. So fractions, they need to have the same denominator in order to add together. So we need to factor out our denominators as much as we can in order to identify what they have in common and what needs to be changed about them so that they can add. So this is what I mean. I have 7 over 9x squared plus x over 3x. Okay? So when I look at this, I see, oh, x over 3x, I can cancel. But don't worry about that right now because this has a 9x squared right there. And so I need both denominators to basically say 9x squared or both say 3x. They need to both be the same. Okay? So I know 9x squared is 3x times 3x, right? Because, 3 times 3 is 9. And the other fraction has a 3x in it. So if I just multiply this other fraction by a 3x, the denominator will say 9x squared, if you want to think of it like that. And then they'd have the same denominator, right? So yeah, I can't just magically multiply in a 3x on the bottom of that fraction, but I can do that if I do 3x over 3x, all right? And the reason why I can do that is because anything divided by itself is 1. 3x divided by 3x equals 1. And if you multiply anything times 1, it's itself. So by doing this, by multiplying that second fraction by 3x over 3x, I'm in turn just kind of multiplying it by the number 1, which isn't going to really change anything. Sure, my numbers will look different, but my in values will be the same. Remember, you can plug in any number you want for x, right? And you'd output the same value. That's basically what's going to happen here. They'd have like the same graphs if you want to think of it like that too. But just think of it, just to kind of simplify it, what you do to the bottom of the fraction, you have to do to the top as well, okay? So all I need to do is multiply this second fraction by 3x over 3x. This first fraction, I don't need to change. That's 9x squared. If I multiply this by 3x, that'll make 9x squared as well, and they'll both have the same denominator. So let's just figure out what x times 3x is. That's just going to make 3x squared. So I have 7 plus 3x squared, but it's technically improper to write it in that order. Plus, I messed up writing that 3 anyway. So I'm going to write 3x squared plus 7. And then I'm going to put over 9x squared. Okay? And this is actually going to be my final answer. I just need to say x can equal 0. Remember, we learned in the earlier videos, 8.1 through 8.3, that you cannot divide by 0. And so whenever you have a variable on the bottom of your fraction, you need to figure out what number can you not plug in that'll make that denominator go to 0. So basically 9 times 0 squared is 0. So 9 times 0 makes 0. So if I plugged in, I can plug in any number I want for x, but if I plugged in the number 0 here, I'd end up dividing by 0 and I'd get an undefined answer. So with every single answer you get, make sure you include that the number or numbers that x cannot equal. And so this one's done. I boxed it in. I just want to add one more note to this. Whenever you're adding fractions and you've come up with the common denominator, don't change that denominator. Only change the numerator. Think of it like this. I'm going to add two simple fractions together. 1/2 plus 1/2. Let's just add the numerators. 1 plus 1 is 2. Let's keep the denominators the same. So the denominator is 2. 2 divided by 2 is 1, right? So anything divided by itself is 1, yeah? So think about it. That makes sense. 1/2 plus 1/2 equals 1 whole. If I have 2 halves of something, I have 1 whole, right? So if I have 50 cents, that's half a dollar. So if I have 50 cents in one hand, 50 cents in the other, together I have 1 whole dollar. Why am I saying all this? Well, if you were to add together your numerators and your denominators, well, 1/2 plus 1/2, 1 plus 1 would make 2, and 2 plus 2 would make 4. That'd make 2 over 4. And isn't 2 half of 4? So if you added together your numerators and your denominators, you're telling me that 1/2 plus 1/2 also equals 1/2. So that just doesn't sound right at all. So you're not getting anywhere if you add together the denominators as well. So keep that, find the common denominator and keep it the same and just combine your numerators. So with that being said, let's do another example. I have 8 over 12x plus 60 plus x over x plus 5. Just because you have x's on top doesn't mean you can cancel it, because this is an x plus 5. So this also needs to say x plus 5 if you were to do any canceling. But right now, the first step is to always find the least common denominator, and so we need to factor. Is there anything I can factor with this fraction? Is there anything in common? In other words, is there anything in common between 12 and 60? Yes, there is. 60 is divisible by 12. So 60 divided by 12 is 5, right? So I'm going to factor out a 12. So I have 8 over 12, and then I'm basically just dividing each term by 12. So 12x divided by 12 is x, and 60 divided by 12 is 5. And so this fraction is now kind of simplified, like I factored out the denominator. And what's nice is I have these two even numbers, 8 over 12. That's a fraction that can simplify, 8 over 12. What's the biggest number that they can divide by? 8 can be divided by 2 and 4, and 12 can be divided by 4 as well. So I'm going to simplify this fraction. 8 over 12 simplifies to make, divide both by 4, so put 2 over 3 times x plus 5. And the reason why I'm simplifying now rather than later is I think it just makes things easier going forward, because we will have to ultimately simplify our fraction at the end. But if you do it at the beginning, then you don't have to do it at the end. And you're dealing with smaller numbers. So I got this from that fraction right there. This fraction, the x over x plus 5, that doesn't change at all. So I can rewrite this now as 2 over 3 times x plus 5 plus x over x plus 5. And so you notice they both have an x plus 5 in common, except this fraction has a 3 and this one doesn't. So guess what? All you need to do is add in a 3 over 3. Remember, what you do to the bottom, you must do to the top. So what's 3 times x? Well, that's just 3x. And so you have 3x plus 2 plus 3x, but the proper order is technically 3x plus 2, over 3 times x plus 5. So I'd accept this for a final answer, or you can write it as 3x plus 2 over 3x plus 15. I got that from distributing the 3 to the x plus 5. 3 times x is 3x, 3 times 5 is 15. So either one of these is good for your final answer. Just make sure you identify what x cannot equal. So I'll put an or right there. And then so we need to identify that x cannot equal negative 5. How do I know that? Because negative 5 plus 5 would make 0, so that'd be turn this whole bottom into 0. Okay? So, and if you think about it, that would make this be negative 15 plus 15, that make it go to 0. So it doesn't matter if you distribute it or not, but I am going to point it out each time that I am able to do it. So say one of these two for the final answer, and then make sure you include the x cannot equal value. Okay, so now I have a subtracting example, and so I have x plus 2 over 2x minus 2. So 2x minus 2, I can break those down. I can divide both of those terms by 2, right? So I can write x plus 2 over, and factor out a 2. Well, what's 2x divided by 2? That's x. What's 2 divided by 2? That's 1. So it says 2 times x minus 1. And then I have minus, and then I have 2x minus 1 times 5x minus 5. Well, what do those have in common? They have a 5 in common. So divide both those terms by 5. So 5x divided by 5 leaves behind an x, minus, well, what's 5 divided by 5? 1. So you see, they both have an x minus 1 in common. So this one has a 2, and this one has a 5. So basically, I can see that I need to add in a 5 over 5 to this fraction, and then I need to add in a 2 over 2 to this fraction, and they'd both end up having the same denominator. So I'll just go to the side of this one, and I'll put times, put a dot for times 5 over 5, and then I'll move to this one, and then I'll put a dot, and I'll go 2 over 2. Okay? Whenever you're dealing with subtraction, I like to just group it together as a negative and distribute it. So I'll put this in parentheses. And so I'll multiply in -2. That way I just don't forget about that negative. And then I'll put this in parentheses and I'll distribute the 5. But the denominators are all the same now. See, I have 5 times 2 times x minus 1, 2 times 5 times x minus 1. The order doesn't matter. All that matters is you have the same terms all on the bottom. So let's distribute those numerators now. What's 5 times x? That's 5x. What's 5 times 2? That's 10. What's -2 times 2x? That's -4x. What's -2 times -1? That's +2. And now let's combine like terms. 5x minus 4x is just x, and 10 plus 2 is 12. So x plus 12. And then the bottom was just 5 times 2 times x minus 1. So 5 times 2 is just 10, right? So 10 times x minus 1. And so I'd accept this as the final answer as long as you said x cannot equal +1, because that would make this say 1 minus 1, and that'd be doing 10 minus 1, that's 0. So you can write that as the final answer, or you can distribute that 10, and you can write x plus 12 over 10x minus 10, where x cannot equal 1. Either one of those is okay for the final answer. So I'll do one more example. I have 5x minus 1 divided by x squared plus 3x. So what do they have in common? They both have an x in common. So we can factor out that x. So I have 5x minus 1 over x times, and then divide both terms by x. X squared divided by x is x. 3x divided by x is 3. And then we write minus, and then I have 14 divided by, and then what is 2x plus 6? What can you factor out from that? Well, a 2. Divide both terms by 2. 2x divided by 2 is x, and 6 divided by 2 is 3. So look, they both have an x plus 3 in common. Only this one has a 2 on the bottom, and this one has an x. So that means I need to add in a 2 over 2 on this one, and then I need to add in or multiply in an x over x on this one. And so by doing that, they have a 2 and x plus 3, a 2 and x plus 3. So my denominators are now all the same. All I need to do is distribute and then see if I can simplify anything. So again, I'll just treat this as a negative x. So let's go back and let's do 2 times 5x and 2 times minus 1. 2 times 5x is 10x. 2 times minus 1 is minus 2. Negative x times 14 is negative 14x. So I have two like terms here. 10 minus 14x. 10x minus 14x is negative 4x minus 2. And then I have 2 times x, so that's 2x. And times x plus 3. And then just identify what x cannot equal. X cannot equal, there's two values since there's two x's. X can equal 0 or negative 3. So most of the time I take this for the final answer, but this is notes, so I do want to be very thorough. What do you notice about these top two terms? They're both even numbers. They're both divisible by 2, and they're both negative. So I can factor out a negative 2 on top. So negative 4x divided by negative 2 is positive 2x, and negative 2 divided by negative 2 is positive 1. And so by doing that, I have a 2x on the bottom, right? And so I can eliminate those 2's. And so I just have negative times 2x plus 1 over x plus 3. And then you just have to make sure you say those exact same values. X cannot equal 0 or negative 3. So yeah, just getting a little technical with that last answer. But that's it for the video. Thank you for watching, and goodbye.